Hello, I'm Mr. Franklin, and today we're going to be finishing our discussion on experimental design. We're going to use a Venn diagram that I've come up with to help us design experiments where maybe we don't have all the answers. Oftentimes in class, we're so used to teacher gives us a paper and we do whatever the paper says. So that's not always available to us. First thing we should look at is what's the question or what's the problem we're dealing with. Then we should determine what is our input going to be. So here, let's just go to this. So here is our Venn diagram. First thing we're going to do is determine what our input is, which is the independent variable. So we're talking right here. It's planned ahead of time. It's going to be measured, and it's an input to the experiment. When we take our data, collect our data, it goes in the x-axis of our graph and our table. Then we need to talk about other parts of the experiment. What are controls? What are some materials we need? We may need to draw a picture of what's going on. And then we need to look at what are we going to be measuring or looking for as a result. Sometimes we don't know exactly what the result's going to be, but generally you should have some kind of idea of what's going to happen, in part just for safety's sake. But there's always something that will happen in an experiment where you're like, oh, wow, I didn't expect that to be the number I got, or I didn't expect that to happen that way. Okay, so just be prepared for that. This also goes on the y-axis of our data table as well as our graph. So we can jump between each of these boxes as we are planning an experiment. And sometimes we have to start here in the middle first before we can go and look at the independent variable one. So it really depends on what we're looking at. When we finish kind of setting it up, then we should write our hypothesis. As the independent variable changes, the dependent variable will change. And when we say change, you should be talking in terms of increases or decreases. Dependent variable will change, increase, decrease, stay the same. How will it change? Just note, this is at the very beginning stages of what we're doing. If you follow this format, you will write very good hypotheses. As your experiments get more complicated, the format may have to adjust a little bit, and you'll see one of those in just a minute. Okay, so pause the video if you need to, get this written down. There's one more thing I want to show you, and that is what I would also like you to write. I'm going to switch cameras here. And so here's our notes that I took. I took it on one page. And then down here at the bottom, usually our independent variable is going to be quantitative. We want to have an actual number. We want our dependent variable to be quantitative if possible, but if we don't have a choice, it can be qualitative. Just know that qualitative is only a comparison. Then we're going to collect the data. It's going to be an input. It goes into the x-axis of our data table, independent variable. It's going to result in a dependent variable, which we're then going to graph. Okay? All right, so now we're going to switch over. We're going to look at our first example. Once you finish the examples, there will be a few practice problems for you to do. Thank you. Okay, so here's our first example. Remember, this is a Venn diagram to help us set it up. Right now I'm doing it big, really large. Later on we'll turn it a different direction and make them smaller. But we're doing it large so you can see what's going on. Okay, so our question is, you have a job working for a journal that compares brands of cars with other brands. You need to test whether a Honda Accord or BMW 330i gets better gas mileage. What is the input? What are we testing? So we're actually testing two different brands. So we've got Honda, and then we've got BMW 330i. So those are our two inputs. Okay, we're going to kind of skip over what are we measuring as a result of the experiment, we're going to be measuring and looking at gas mileage for our result. Okay, so now we need to talk about what are the things we need to do to set up our experiment. So what are some things that we need to make sure we're careful of? Okay, maybe the course the car drives on. Maybe how the person drives. They should drive the same distance. Let's see. And we may want to ensure that parameters like how much fuel is in the tank, course conditions like weather are as much the same as possible. So those are some things we want to control. In this case, doing a picture is probably not going to help us because we may not actually have access to what track we're actually going to use, but we know what we need to be thinking about. So we're going to drive these two cars. That's our input. We're going to do these things to control the experiment, and we're going to measure this as a result. So let's write a hypothesis. So my hypothesis is, as the independent variable, which we're going to be specific, so as the Honda drives on the course, it will get better gas mileage than the BMW. BMW. Notice it's not like in maybe the exact order I talked about, but as we switch cars, as we switch from the Honda to the BMW, there's our independent variable. We're going to measure the gas mileage, and I'm making a prediction that the Honda is going to do better. I could be absolutely wrong, and we would have to do the experiment to find out. Okay? Okay, this next one, we're going to do experiment 2. So this time, we're going to go ahead and turn our paper sideways just so we can fit more of these in, and we're going to do it a little smaller. Okay? If you need to use the whole page, go ahead and keep using the whole page. But we're going to go ahead and start making these a little smaller so you can fit more than one on a page. So, you have been tasked with finding out if vitamins actually benefit people who take them. Okay? So, I'm going to pause the video right now and see and try to fill out your experiment on your own, and then when you're done, unpause it and see how you did. Okay, I hope you paused it. So let's check what you came up with. So first thing, independent variable. What's the input? So the input is going to be vitamins. Vitamins or no vitamins. Now we could get more complicated and we could look at different types of vitamins, but we're going to keep it simple. Vitamins or no vitamins. We could do Flintstone vitamins, we could do gummy vitamins, we could do all kinds of different ones, but we're only going to test vitamins or no vitamins. What are we going to measure as a result? So the word is benefit people, but that's really not measurable. So what is something that would show a benefit that we could measure? So we could do a medical exam maybe, before and after, and check overall health. So notice I'm actually brainstorming. what my DV might be. We could do a health survey, ask the patients how they feel. We could give a fitness test. We may have to do all three of those things, or we may just, because of our situation, may just pick one. Okay, so that would be something you would have to figure out. What are some things we'd want to keep the same? We'd probably want to have same types of people taking it. If we're only testing children, we should only test children. If we're testing all ages, we should have all ages. We should have one group that does the vitamins and one group that does not. Okay? Which actually leads us into a term that we're going to review, and that is control group. A control group is the group that's doing things as normal. Doing things as normal. So that, in this case, who would be living life as normal? Well, hopefully it would be this group, but it's actually going to be this group, no vitamins, because we're actually testing if vitamins work. That would be the control group. Okay, same type of people, same type of vitamins, same number of vitamins. So basically another way to think of control group is basically the people that are doing only the stuff that's in this box. They're the control group. And then we have our experimental group, which is also doing this part that's outside the box. Okay, so now, hypothesis. As the group that takes vitamins as the group takes vitamins here, let's see, as the group takes vitamins, they will perform better on their fitness test. Okay, all right. Let's take a look at one more, and then you'll get to do some totally by yourself. Okay, here's the next one. You're going to design a new soccer ball. You want to know if more panels or less panels affect the amount of control a player has on where the ball goes. So we got a 32 panel ball, 14 panel ball, and a 6 panel ball. Each one of these was actually used in a World Cup game. So we're going to design an experiment. Which one would a player have more control over? Okay, so draw our box and go ahead and set up an experiment to test it. Okay, pause this video and then I'll show you what I came up with. Okay, this is what I came up with. So it's just a design. There's no way to know if it's correct or not because I'm not a soccer expert. So 32 panels, 14 panel, and 6 panel were the 3 different soccer balls we were going to test. Skipping over here to the dependent variable, I decided that I was going to go with a goal with targets or cutouts. So I've seen this done with hockey. I believe soccer, usually they have a net with actual holes put in the net where it'll catch the ball, but they can't shoot anywhere where there's not a hole. In hockey, I've seen it where it's like more like a cardboard thing or a cover over the goal, and then there's these holes where you have to hit the target for the hockey puck. But I thought of that for the soccer ball. I thought we should have a number of kicks, so 10 kicks, 2 at each target. We should have the same kicker, the same field, the same goal, same weather, try to keep everything the same, and then we'll kick and see how accurate this is going to be. So my hypothesis was, as we have fewer panels, the soccer ball will have more control and accuracy. So Now we have enough that we could set it up and go run the experiment and then analyze it. Okay, so now in Google Classroom, you have, I believe it is 4 more of these to do on your own. And when we come back, we will check those and see how you did. Thank you. Bye.